my name is Ashley Booth, and this is my Lab 1 constant velocity video. Here is my table of contents for the video. The purpose was to demonstrate Newton's second law in regards to objects rolling at a constant velocity. For this lab, my group used a bottle of Expo marker remover for our object, and I did not include any external or applied forces in my calculations like air resistance or friction, and I only recorded movement on the x-axis. Some key concepts starts with Newton's first law, which means objects will remain in motion or at rest unless acted on by an unbalanced force. And then that can go into Newton's second law, which states that the net force is equal to the change in momentum over the change of time. And since momentum is a quantity of motion of a moving body, since ours is consistent, it would equal zero, meaning our F net would equal zero. Then we can put this into the velocity update formula, and since F net is still zero, that would just mean that the final velocity is equal to the initial velocity. And finally, we can put that into the position update formula, which just states that the final position is equal to the initial position plus the final velocity times delta t. The procedure, my group recorded the object rolling at a constant velocity in a straight line. I imported that into Tracker to track the center of mass for the bottle over a period of 1.67 seconds. Then I calculated the initial velocity, the timestamps, and determined the initial position. Then I created a computational model to calculate the predicted position data, and then I compiled the observed and predicted data to generate a graph comparing both set of data points, and I found that the graphs were very similar and both linear. I also wanted to state that the system is the bottle. The surroundings are everything around the bottle, like the meter stick, the floor, the air, everything. Here is my tracker. The red diamonds show where I started to track for the bottle. And in the top right, we see the graph, which is linear, and the data down here. And with this information, I calculated the initial velocity, which is the change in position over the change in time. And for this, I used my very last position data point with my very first position data point to get a velocity of 0.271 meters per second. Then I started with my computational model, and I researched that the average mass of the bottle was 0.27 kilograms, and then I updated the initial position and the velocity. The initial position was 0.147 meters, and the initial velocity was calculated before, the 0.271 meters per second. And my delta t was 0.033, since that is how far the timestamps were from one another. Then I used the initial conditions for the rest of my computational model, where I set time is less than 1.67 seconds, since that was how long my video was. F net is equal to 0, since it's constant velocity. And then I plugged in the initial velocity into the velocity update formula, which just gives back that the final velocity is 0.271 meters per second. And then I plugged that final velocity into the position update formula. And overall, I created a graph that has the position over time, which is shown with this. And since it is linear and increasing, it is just showing that there was a constant velocity over time. There was a consistent change in position throughout the video. And here is that predicted versus the observed position. The red line is my predicted data, and my blue line is the observed data. Since they are both linear and increasing, it does show that there was a constant velocity for both. However, they are slightly different, and I will talk about that in the discussions. So some possible errors were that the bottle did roll with a slight curve in the video, although that curve was not directly tracked for the most part. There could have also been friction from the floor, which caused the observed data to curve a little. Also, in our video, we did accidentally record the applied force being captured. However, it was edited out and not tracked. And if the axes were interchanged, that would just mean that the principles would stay the same. The velocity is still constant, but the slope would be negative. So instead of going from left to right over the time, we would go from right to left. But it would still be constant. And since they are similar, there was probably forces that did end up canceling out. But since they are just a little bit different, we can assume that there were smaller forces such as friction and gravity at play. Thank you very much.